feel free to spend the next 30 minutes having a bit of a snooze if everyone's a bit full after lunch, siesta or a siesta. So yeah, my name's Sam Sharp. I'm a recent LabVIEW champion, yay. Architect, see you here, thank you. LabVIEW test and developer, and I run my own little sort of alliance partner company. Today I'm going to be talking to you about databases, kind of how we can do things a bit better in LabVIEW. But first, basically, I'm going to embarrass my mum. So I've picked her for our Giants Are Female. She's having a pretty rough time at the moment, these last few sort of weeks and months. And really, there's no one that I look up to more than her. She's made so many sacrifices to kind of allow me to be here today. She raised me single-handedly. She's a fantastic artist, art teacher. And she has a shed full of power tools that would put even most men to shame. So, she's she really is a role model. I'm just going to be really cheeky. Can we just get a round of applause just for my mum, because I should really appreciate it. Okay. Okay. Thank you very much. Moving on. Just a very quick note as well. Some of you may know that I wrote a LabVIEW WebSockets Tool Kit for the community. I just wanted to let you know that very soon there's going to be a new version of that coming out. It's had a sort of a fairly major rewrite, kind of simplify the API, to make fix some bugs, make some improvements, and yeah, it's going to be available on the tools network soon. You might notice from over here, there's some experimental secure WebSocket support in there as well. So keep an eye on that, because soon that'll be available as well. Okay, so onto my presentation. So a lot of my career in one form or another has revolved around talking to databases. So I kind of started off from school doing web development, sort of did that as a sort of freelance career for a bit whilst I was at university, basically writing web-based applications with PHP, MySQL, and then kind of I didn't really leave that behind when I moved over to LabVIEW, writing applications to talk to databases, whether it's monitoring a lab of test stations, or writing a custom database for storing test results from a test stand system. And the one thing that I come back to is that communicating with databases in LabVIEW, it's tedious. Writing VIs to talk to a database with anything more than a few tables takes a long time. A lot of it is repeated, dull work. It's a boring and thankless task, and I hate it. Right, so before I get into the kind of the sort of the bulk of the presentation, I just wanted to give a kind of a sort of an overview of databases, offer a few sort of hints and tips and that kind of thing. So, I mean, first of all is, well, when would you use a database? So basically, if you're trying to do any of the things on the left-hand side here, like if you need to store large amounts of information, if you need to share data between between users, if you want to have to be able to back up and restore, chances are you should probably put Excel down, put your files down, and consider using a database. It may be that it's not the right answer, but you should probably have a look at it. Databases come in many forms. So, for example, they're kind of categorized into two main types. There's a third one, but I'm not going to cover that here. Basically, relational, which is where you have tables, and tables of rows and columns, like your sort of Excel worksheet. And those rows and columns are linked through relations. So, if you have a customer might have multiple orders, standard kind of example speak there, but that's the kind of idea. And there's quite a few sort of well-known ones up there, so like MySQL, MS SQL, Oracle, blah blah blah, SQLite, things like that. There's also the other kind of main category is NoSQL. So this is basically sort of unstructured and semi-structured data can basically be stored and manipulated. It's kind of, think of it as like a way of storing documents. So you write a document to your database, and you can then update it, modify it, and that kind of thing. When it comes to talking to databases in LabVIEW, out of the box, we have the Database Connectivity Toolkit, but there's also other third-party toolkits, so like SQLite, which James is going to talk about after me. I think there's also like a GDevCon toolkit as well, so there's other options around as well. I'm going to focus here on the Database Connectivity Toolkit, just because it's the one that's in LabVIEW and it's free. This is kind of basically what a database operation with the DCT looks like. So over on the left-hand side, we are establishing a database connection. A lot of people don't know that you can wire different things in here. So if you can wire a path to a UDL file, which a lot of people do, but maybe they don't realize that you can just specify it by name, or you can kind of build up the connection string. There's like a website you can do that will generate it for you, and it's kind of another way of doing it. I see a lot of people like applications that randomly have like connection files in them, and I think it's just because they didn't realize that you can specify a string instead. And then we're basically selecting some data from a table, converting it from this kind of 2D array of database variants kind of into our rows, and then closing off the database connection. Depending on what kind of database you're talking to, you might need some like extra drivers to install. So things like for MySQL, the ODBC driver, MS SQL, the SQL native client, and then you can kind of configure those from the from Windows. A couple of like best practice hints and tips I've kind of picked up over the years. So in terms of sort of security and robust applications, one thing that you should be aware of is SQL injection, and this is kind of highlighted over here. Basically, this XKCD is a sort of perfect example of this. Of if you put in some malicious string as your sort of username or as a user field, you can do things like drop tables, delete your database. Obviously not good. So someone with malicious intent could do that. So the way you kind of get around that is basically by always use like parameter binding. Don't do this thing here where you're kind of formatting things into strings. From user input. Use the it's a bit more long-winded, but yeah, use the parameter binding when you do that. Also, passwords in VIs. If you've got VI server, you can kind of read the boundary of a sub-VI. So if your password is in like a constant VI that comes out, then someone could list the VIs in memory and run your VI, and they found out your database password. Just something to be aware of. Again, as well, kind of similar vein, limit the application's access to the database. So if you know that your application should only be inserting test results, then they don't need access to write to the operator table, for example. It's just one way of sort of kind of limiting the amount of damage that could be done. Performance-wise, don't repeatedly open and close the connection, especially with over a network. It can take a few seconds to connect to the database, but once it's there, it's quite quick and performant. So yeah, if you're opening and closing it every time, then you can get some delays in there. The other big thing about performance is kind of how you handle the design of your database. So it's really it's quite important. Like when we write software, we have to think about the design so that our software does what we want it to do and performs how we want it to do. The exact same thing applies to databases. So if you have a poorly designed database, then you're going to run into issues, especially in terms of performance. If you're starting to insert, millions of test results, then having a poorly designed database can cause the whole thing to come to a halt if it's not written correctly. There's kind of a thing here about like the guiding principles of how you kind of take, I want to store this data in a database, and how you come out with your kind of database design is kind of follows the normalization principles. So this is kind of a defined set of rules that basically says, if you have duplicated data, then that should be, you shouldn't duplicate data. And basically, yeah, there's a bunch of rules there that say, this is how you should guide your database design. But they're kind of, it's a tool. You don't have to follow it to every letter, to every single principle. Sometimes there are, times when it's time to break the rules because you don't need to go that far with it, and sometimes it makes sense rather than to keep things simpler, because each time you add a new relation or a table, the number of things that you have to deal with kind of increases exponentially. So the question is, so now getting onto the kind of the bulk of the presentation. So this is kind of a sort of an example database schema that I kind of designed for storing test results. So we've got a test execution table. It kind of follows test stand a little bit because that's what it's based on, but follows a test execution. Then we have an operator table. Our test execution has multiple test steps, and each step can have one or more measurements. And I guess the question is how long would it take you to write the LabVIEW VIs to kind of, to do the kind of basic database operations for these tables? So we've got 5 tables, 4 operations, let's say, 20 VIs maybe. But anyone want to shout out a guess as to how long they think it would take them to write VIs for this? Way too long. A day, half a day. It's not it's more than a few minutes. Okay, so let me show you how it can be done in 90 seconds. Okay, so you'll notice immediately that I'm cheating. This isn't LabVIEW. What I'm doing is basically kind of going back to sort of my web developer days. There's a framework called Yi, which basically is for writing web applications. So you see there, what I've just done is configured a database connection. I now go to this super special link, click on the create models. We're going to create models for all the tables. We can see it's pulled in all of our different table names. We can preview the code, which has got all the fields in there. It's text-based. You just switch off at this point. That's fine. We then generate the models. So this has now generated the files. We can now go into the CRUD generator. And basically, so CRUD is create, read, update, and delete. And we can now create some code for our operator table. I'm just setting up with the file paths. We can see there it's created a bunch of files for us, or about to create a bunch of files. Generated the files. And then we will go to our new operator controller. So basically a special link, and you can see now we can create a new operator. Select our privilege type. We can now view our operator. We can view a list of the operators. We can update it, and we can also delete as well. So basically, we've created all of that code for these tables, in a pretty short amount of time. So to recap, we've fit in that 90 seconds. Sequences have been shortened a little bit, so just as for the sake of time. But what we've done, we've configured a database connection. We've created model classes for 5 tables. Basically, a model is one model represents one table in your database, but I'll come on to that a bit more in detail. The columns are our model properties, and it's already doing some basic validation, like if the field is required in the database, then it's got to be required on the the user interface as well. And create the user interface. So and we've done all that without writing a single line of code. All we've done is entered some configuration strings. Isn't that great? So just a kind of an overview of how it did it there. So it's the Yi PHP Framework, which basically implements what's called a model view controller. So it's a concept not specific to Yi. It's quite there's other languages as well that kind of follow the same principle. But basically, you have a model which kind of represents an object. I hate using these examples, but an order or a test execution or something, and that's then also modeled in your database. You then have views, which are then used to present the data in those models to a person, and then the controllers are used to kind of implement the business logic, the kind of the meat of our application. And that's the kind of bit that we like spending our time on. We don't really like doing user interfaces. We don't really like writing model classes. It's boring donkey work. And the Yi framework has got tools in it which allows you to kind of automatically generate, all 3 of those. Obviously, you have to kind of fill in the blanks for the business logic, but essentially it will create a lot, do a lot of this boring work of creating these files automatically for you. So I guess the crux of this is what if we could do some of this in LabVIEW? Wouldn't that be great? So basically, the main thing that kind of drives the models is this concept of an active record. So basically in Yi, ActiveRecord is like the implementation of the models. So an ActiveRecord object, so we're kind of getting into this kind of class stuff here, is that basically the ActiveRecord object contains persistent data. This is a database store of data, and then behaviors that act on that model. So kind of the way that it's often treated is that we have one class represents a table. A row in your table is then an instance of that class. And then your columns of your table are the class properties, and then we have methods which act on, perform your kind of basic operations like insert data, increment view count, something along those lines. So the purpose of these is to represent the models and their data. It also represents relations between models. So obviously, in a relational database, you have one-to-many relationships, many-to-many relationships, and so the idea of the ActiveRecord is that that's also supposed to, represent those relationships as well. It also is responsible for things like validating the models and performing a kind of low-level database operations, inserting data, et cetera. So kind of to show you the kind of workflow is that this is our table. We've then got kind of converting that into sort of an ActiveRecord class design, and then we want to generate an operator class which with those fields as properties, and then some methods to be able to get an operator by their ID in the database, and then we can kind of string all that together, write our properties, insert, update our data in our method, save it, and then read out the primary key just to check that it's inserted, and then delete it. Okay, great. This looks like it's kind of moving in the right direction. So I'm now going to show you how I have done it in LabVIEW. So the first thing I'm going to do is go to my little tools menu, my ActiveRecord database thing. It hasn't got a name yet, so yeah. I can then connect to my database. I can then select my tables. I can say which fields that I want to generate, but which fields I want to kind of include in the model. So I'm excluding the ID, because that's handled by the sort of parent class. And I want my level to be an enum rather than a string or a numeric. I'm then going to do the same thing for my test execution table. So for example, my archived, some databases store Booleans as a number, so I'm just going to correct that and say I want that to be a Boolean, and my result, pass, failed, done, I also want that to be an enum as well. So we'll then, with a little bit of speedy up magic, generate the classes, generate the class for this table as well. Now that's done. We can now see in the background that we've now generated 2 classes, so I'm going to add those to my project. Needs some like Benny Hill music or something, I think. And you can see there we've got our class with its properties. And what I'm just going to do now is automatically created the type defs for my enums. So what I'm just going to do is populate what those values should be. You can tell that I didn't, the spelling mistake included. And now I can start building my application using my new classes. So I drop down an instance of the test execution. Some of my fields are required, so I'm just setting up, writing the data for those particular fields. At the moment, there isn't any validation in this, so I'm not quite there yet with it. But yeah, so I can put in my data. And you'll notice as well, it's automatically picked up the data types as well. So, the timestamp has been picked out as a LabVIEW timestamp. Some databases deal with them, again, in a different way. And now I can do save. So basically, save is if it's a new record, then insert. And if it's an existing record, then it will update it rather than insert. It just simplifies what you're trying to do in your head, because you can just use the same save VI further down the line. And then we can see we've run it. We got back a primary key. So that's a pretty good indication that our data is in the database. OK, so that took about 2.5 minutes. So in that time, we have sort of configured a database connection. So I've kind of already put those steps in there, but I've got some kind of helper classes and some helper stuff that kind of helps you do the sort of wrap up the database connection. We've then generated some model classes. I've only done 2, but again, just for shortness. Again, 1 model class per table, columns as model properties. We don't do any basic validation yet, but that's kind of something to do in the future. We've, again, created our VIs to kind of do our basic database operations, so create, update, insert, create, read, update, delete. And yeah, from our test execution table. So once again, we've done that without writing any SQL queries. We don't need to know SQL to be able to put data into this database. We haven't really done much LabVIEW code. We haven't had to write all those VIs by hand. It's given us more time to develop the sort of business logic of our application. Again, frameworks, pretty cool. Okay, so the current features. So I have this kind of ActiveRecord base class, which allows the sort of basic functionality of create a record, read, update, delete. I've added just this week the sort of scripting of generating those classes automatically, and the integration into like the LabVIEW tools menu to kind of tidy it up a bit. And then there's a few sort of like supporting libraries and tools that are kind of involved in this as well. So there's a database connection class which kind of encapsulates being able to talk to different database types, or using a different database toolkit. So if you wanted to do an SQLite version with James's library, then you could wrap that up into this ActiveRecord implementation. There's also a query command library. So again, what Yi does is it allows you to kind of build up an SQL query through a series of like methods and properties, rather than having to know, oh, what's the syntax for getting the last inserted record ID? What's the syntax for inserting a string? This abstracts all that away, and so you can kind of build up a string here. Or, you can build up a query here of select from the operator table where the ID is 1, order by the full name, and limit to 5 results, and then generate the query. So you could say this is a bit more long-winded than just writing the query out, but you'll notice here that I'm actually doing the parameter binding in here as well. So that extra code or those extra few VIs you have to put in to do the parameter binding, that's all taken care of as part of this library. And then finally, I've done this integration of building it up into a tool that you can use as part of your LabVIEW applications. In terms of future functionality, so at the moment there isn't much in there by the way of like pulling out data from the database, because obviously you've got retrieve a record by ID. You might want to find all rows. You might want to find all rows with certain attributes. All the kind of things that you would normally do in database queries. But so I haven't really thought too much about that yet. Also implementing things like model validation. So before we try and insert the data into the database, let's just check it. Check that things we have required fields, that we're inserting default values or null values where we're supposed to. That kind of thing, because then you can kind of show that as a nice error to the user as part of your user interface, rather than some database error that it's thrown out that they tend to be quite cryptic sometimes as to what's actually going on, and it could just be, oh, I've forgotten a field, or something's not named correctly. Also implementing like foreign key relations, so basically saying, oh, our test execution, retrieve a test execution that has multiple test steps, and from there, pull out, what's the sum of the execution time. It's that kind of thing that kind of makes this more powerful. Of rather than having to say, oh, okay, I want this, but it's also on this, and so I've got to join these, and have the kind of have that functionality built into the library. I think would be quite nice. Also, the other thing that Yi does as well is, and other like web languages do, is like the idea of like interface binding. So this is basically where you link a model to a user interface, and when the model changes, the user interface automatically updates. So again, we don't really like writing, user interface code. It tends to be a necessary evil, and doing things like validation and field validation on user interfaces, it's not a lot of fun, takes a long time, and it could be smoother, let's say. So yeah, that's another thing that I think would be quite nice in here. So at the moment, this is just, it's something that I've liked. I like this principle of ActiveRecord from Yi, and it's kind of something that I've always, because I've done a lot of work with databases in LabVIEW, I've always kind of wanted to do things a bit better. And so this is kind of, it's just a kind of a bit of a hobby project of, can we, incorporate some of this, but if people want to give me feedback, then drop me an email or whatever, and I'll be happy to talk to people about it, because I think I'll get a lot of use out of this, so I'm hoping that other people will as well. Thanks for listening. I've got about 5 minutes left, so yeah, I can take some questions, but yeah. Yes, sir.
So you mentioned like contributing and helping out. Is this an open source project, or is this like something you're trying to sell as a toolkit? Or?
It's too early.
I just asked about if this was going to be an open source toolkit, or what your thoughts were.
At the moment, it's too early. At the moment, it's just a hobby project. I have no plans to commercialize it. I don't know what would happen in the future. At the moment, I think I will keep it, make it open to the community, but don't hold me to that. If we have to kind of see how things go. But yeah.
Okay, thank you.
Any more? Oh yeah. Carl.
So with the schema that you showed,
yes,
how easy it is to add different types of schemas to it?
So if I go back to, where is it? This slide. So what, hang on, where's the screenshot of the, no. Yeah, so that, dialogue that I showed as part of the LabVIEW video, that basically you give it a connection string to a particular database, and it will retrieve the list of tables that are in that database. When you then select one, it will pull the list of all the fields in that table. So it's all done dynamically, and then the scripting tool just says, from, with these field names, basically create, a class based on my ActiveRecord template class, containing these property fields, and then you can read-write to them. But the operator class or the test execution class is very thin. It only has like a couple of VIs that you have to kind of include or overwrite, but everything else is kind of automatically scripted and or handled by the parent class, which does the inserting, deleting, etc. Yeah,
that's a great answer. So we have something very similar to this at Renishaw, an internal tool to create all the tables as well as creating your libraries and things. Yeah, it'll be great to have a chat later.
Yeah. So this is like it's a one-way. So yeah, you already have your database set up, and I want to talk to it from LabVIEW. Let's generate all the generate all the VIs and classes to be able to do that. Okay. Yeah. Question down here.
Where can we get this toolkit?
So yeah, it doesn't exist at the moment. At the moment, it's yeah.
Oh, you tease.
Yeah, it is. It's the presentation is an expression of this is some things I've been thinking about. These are some tools that I think will help me, but at the moment, I'm still working on them very much. So yeah, I need to make decide one way or another. But I'm I think. I hope that this method is something that that you can learn from. But yeah, I'm hoping that we can do something of releasing it and that kind of thing and getting it out there. So yeah, at the moment it's not available. At the moment this is just me playing around with it. I did all the scripting stuff for it on Monday. So yeah, very much not a toolkit yet. Yeah.
So just out of curiosity, maybe we can help them out. How many people think this is a very interesting project and would use it if it was available?
Okay, good.
Stuff like that. Yeah. Not that I'm trying to create more work for you.
No, you're trying to create a revenue stream for him.
Yeah.
I would pay for that.
Yeah. That's not not the purpose of this presentation. I just wanted to kind of show what I'm looking at and looking at how other languages do things and how we can kind of speed up how we do it in LabVIEW. Okay. Yeah. Yep.
Would you put some early functionality in it, do that with all the products in the class-based stuff?
I don't know. I don't want to get too far as specifying what your application architecture should be. So I'm just looking at how we can speed up the sort of the communication with the database side of things, rather than rather than the other way around, I guess. So it's because quite often, in the applications that I've worked on, it's usually you're talking to an existing database, and you need to insert some data into it, or you need to check some data into it, rather than building up from scratch. But it's something. Feel free to have a chat with me afterwards, and we can talk about what we're. I'll probably take one more question.
Sorry, I was just going to say, can you, if you need to change your schema in any way, have you thought about handling how you'd reintegrate that to the classes that already exist? Or I'm assuming you haven't thought about it yet.
Yeah. The answer is a very simple no. It'd be really nice to to have the two-way. You can do this in some like database modeling tools where you can have so this diagram. Where's it gone? This diagram is generated from the database, and you can then do the reverse as well. You can have it. You can update this, and it then updates the database schema. But that's opening a big can of worms there and a kettle of fish that I haven't thought about yet. But yeah, it'd be nice. But that kind of two-way integration, because obviously you might want to customize your classes to have have additional methods based on your models. Often it's not just for inserting data to the database. You also use it for things like adding customers, or adding other stuff that's beyond just the basic database operation. So you wouldn't want to overwrite that by updating your model. So that's okay. I think that's it for time. So thanks everyone for listening, and